Okay, this is my screencast video assignment 3. It was over second order linear homogeneous differential equations with a constant coefficient. We have constant coefficients over here, a, b, c. It's second order because of this y double prime, and it's homogeneous because it's homogeneous when d of x is equal to 0. In order to solve these, we have to have the characteristic equation, and it's right here, m squared plus am plus b equals 0. And by doing that, it could be either an easy factor where we don't like need to use the quadratic formula, or we're gonna have to use the quadratic formula if it's not an easy factor in order to solve these differential equations. So right here is case 1. It's unique roots. As long as the roots are real, we could use the general solution of y of x equals c1 e to the m1x plus c2 e to the m2x. So we got to solve for m1, m2. Um, so here we're going to use my numbers that I've chosen, and we're going to put into that differential. So it's going to be y double prime plus 6y prime plus 8y equals 0. Now, in order to solve for that, we have to plug it into the characteristic equation, which is m squared plus 6m plus 8 equals 0. Now, this is an easy factor. We don't need the quadratic. So it's going to be m plus 4 plus and m plus 2 equals 0. And then we're going to get m1 is equal to negative 4, m2 is equal to negative 2. And then we plug that back into the general solution. So it's y of x equals c1 e to negative 4x plus c2 e to the negative 2x. I don't know why I don't have the x. I must have forgot it. But yes, we use this general solution when the roots are unique and real. Case number 2 is the similar roots. It's like when roots of the characteristic equation are same and real, we're going to use the general solution of y of x equals parentheses c1 e to the mx plus c2 x e to the mx. We're going to use the numbers that I chose, and we're going to plug it into the differential. It's y double prime plus 8 prime plus 16y equals 0. And then in order to solve it, we have to plug it into the characteristic equation. M squared plus 8m plus 16 equals 0. By doing that, we could factor it out to m plus 4 squared, and it's going to be m equals negative 4, negative 4. So these are same roots, and they're real numbers. So now we can plug it into the general solution because it meets the criteria of the similar general solution. And then it's going to be y of x equals c1 plus c2x, and then multiply e to negative 4x. I decided just to factor out the e to the negative 4x out here just to make it look nicer. So finally, case 3, it's complex roots. Now, the other two, they have to be real. This one is for only imaginary numbers. So when roots are imaginary, we have to, and it's equal to m1 equals a I plus ib. Well, a alpha I plus I beta, comma m2 equals alpha minus I beta. So right here we have the general solution. If we meet the criteria, it's going to be y of x equals e to the alpha x, parentheses c1 cosine beta of x plus c2 sine beta of x. So now we have y double prime minus y prime plus 5y equals 0. By using the character, that's the differential, but now by using the characteristic, we get my m squared minus m plus 5 equals 0. Now this doesn't factor easy. You're going to have to use the quadratic. So right here, m equals plus 1 plus or minus square root of 1 minus 5 times 1 divided by 1. And we get, and that equals to plus 1 plus or minus the square root of negative 4 divided by 2. You can't have the square root of negative number, so it's an imaginary number. So it's plus 1 plus or minus I, the square root of 4 divided by 2. So now we're going to solve, skip m1 and m2. So m1 is 1 plus the square root of 4i divided by 2. m2 is equal to 1 minus square root of 4i divided by 2. And we get our alpha is equal to 1/2, and our beta is equal to the square root of 4 over 2. Now we met all the criteria to plug it into the general solution for like imaginary numbers. So right here is y of x equals e to the x divided by 2. and in parentheses c1 cosine square root of 4 over 2x plus c2 sine square root of 4 over 2x. So that was the last solution. So basically, we get a differential, we use the characteristic to solve it, and by using the characteristic, we find the roots, and by the roots, we could tell what general solution to use. One that's for unique roots, one is for similar roots, and the other one is for imaginary roots. And that's all there is to it. Thank you.